Okay, let's look at this problem right here, problem number 11.65. It's problem set 11.3, and it's about unit cells. The question is, what is the length of an edge of sodium fluoride? It asks us to go to chapter 7 to figure those radii out, and they're here, and so I've already listed them for you. 1.16 angstroms for the sodium, and the fluoride is 1.19. Okay, we need to understand what a unit cell is, so go to page 462 in your book. On page 462, there's a great picture of a unit cell that's exactly the kind of thing we're trying to understand. This is called a face-centered cubic. You can see that in the face of every cell, okay, there's one atom, or the face of an atom, so that's why that's called a face-centered. Now, one thing that you don't see is also in the middle of this, in the very middle, there's a complete chloride atom as well, chloride ion as well, okay? Now, along this edge then, how would we do this? Well, this is one radius here, and this is two radii here for the sodium, and then one radii here for the chloride. So that looks like that's all we have to do. So let's go back to this. And so the length of a unit cell is going to be, we're looking at something like this. We have the chloride here, the sodium, or actually this is fluorine, and the fluoride here. So you can see that that's one whole diameter and another whole diameter. Okay? So that's 1.16 times 2 for the sodium, 1.19 times 2 for the fluoride, and so that turned out to be 2.32 2.38 4.70 angstroms is the edge. Okay? The next question is part B, and in part B, they're asking us to solve the density. The density of anything is its mass divided by its volume. Well, the volume is going to be pretty straightforward because we've just figured that out, that the unit edge is 4.70 angstroms, so the volume is 4.70 cubed, right? But one thing I want to do is to convert this to, because your densities have to be in grams per cubic centimeter for little tiny things like salts and things like that, grams per cubic centimeter. Okay? 4.70 angstroms is the same as 4.70 times 10 to the negative 10th meters, and that's the same as 4.70 times 10 to the negative 8th centimeters. Okay, so now I need to cube this number because the volume is just the sides cubed, and so side cubed, the volume would turn out to be 4.70 times, this is a bad calculator, this doesn't have a cube function on it, but it's a 103.8 times 10 to the, and this is negative 8 times 3, so that's negative 24 cubic centimeters. Okay, this is not proper scientific notation. I could fix that right away. 1038 times 10 to the negative 22nd cubic centimeters. Okay, so how do we get the mass of this? The mass of all of the atoms in one unit cell. Let's do that. I'm going to draw your attention back to this page right here, page 462. Look at this cubic crystal and see if you can't tell how many ions are in the whole thing. This counting is illustrated for you right in this problem, right beneath this, if you don't understand this. It's also better illustrated right here, perhaps, okay, on the previous page. That's on page 461. So notice that you have these things in here on the face center. You have these in the, and this is half of a sphere. In the corner, you have an eighth. Okay, so that's 1/8, 1/8, 1/8. So that's the kind of adding we're going to have to do here. So, looking at this picture, the chlorides we'll do first. There's 1/8 of 8 right here. chloride. 1/8 of 8 on that top. See, there's 8 corners, okay? And then you see there's a half here and a half here, and there's 6 faces. So it's 1/2 times 6. Okay, so what does that turn out to be? That turns out to be 1 plus 3. So there's 4 chloride ions in there. Let's do the sodium. Oh, I shouldn't have called that chloride. It's actually fluoride. Okay? Now the sodium is the smaller balls. So let's look at those. On this edge, there's 1, 2, 3, 4, but you'll notice that's a quarter of a sphere, so that's 4 times a quarter, and then the top and the bottom, and these right here, so that's really 12 times 1/4. So 1/4 times 12 plus, now what you don't see, and this is a trick because it caught me at first, inside the very middle of that there's 1 sodium ion, so that's 1 more sodium ion, and so that turns out to be 3 plus 1, so there are 4 sodium ions. You know, that makes sense because what's the formula for sodium fluoride? It's NaF, so there has to be a 1-to-1 relationship between that. Okay, so now we're going to do a little bit of math. For the fluoride, okay, we're going to do the mass of the fluoride, and then we're going to find the mass of the sodium and add them together, right? And then that'll be the total mass divided by the total volume, and there's the total volume. We'll be done. Okay, so how many fluoride ions are there? What's our given, in other words? There's 4 fluoride ions. Okay, there are 6.02 times 10 to the 23rd ions in a mole, and a mole of fluoride weighs 19 grams. Okay? So this turns out to be 4 times 19 divided by 6.02. So that turns out to be 12.62 times 10 to the negative 23rd. Move that 1, so that's 1.262 times 10 to the negative 22nd grams. Notice how that my units have all canceled just like they're supposed to. Okay. 1.262 times 10 to the negative 22nd grams is the mass of the fluoride. Sodium works the same way. 4 ions of sodium, 6.02 times 10 to the 23rd. Ions of sodium is a mole of sodium, and a mole of sodium has a mass of 22.923. Okay? So that turns out to be 23 times 4. 15.28. Which is 1.528 times 10 to the negative 22nd grams. So now I'm going to add these two together. I'm going to add the sodium mass to the fluoride mass, and so since I already have that in my calculator, it's 1.528 plus 1.262. So that's 2.79 times 10 to the negative 22nd grams. This is one thing that I always preach, that you think about what your unit for density is, and the unit for density is grams per cubic centimeter. So there's my grams, 2.79 times 10 to the negative 22nd grams, divided by the volume, 1.038 times 10 to the negative 22nd cubic centimeters. Now let's think 1 second. You always kind of want to think, are you on the right track? 2 divided by 1 is going to be a number bigger than 1. Is sodium fluoride denser than water? Yes. So this is going to be a sensible answer. So all we have to do now is divide 2.79 by 1.038, and we get 2.3. What are our units? Notice that everything else cancels. We have grams per cubic centimeters, and we're done. There's the length of an edge, and there's the density of sodium fluoride.